A part 1. Taking the radius of the Earth, r is equals to 6370 and pi is equals to 22/7. Calculate the shortest distance between the two cities. P, 60 degrees north, 29 degrees west, and Q, 60 degrees north, 31 degrees east, along the parallel of latitude. Part 2, the question: if it is 12:00 hours at P, what is the local time at Q? Part B of the question. Part B of the question is an aeroplane flew due south from a point A, 6 degrees north, 45 degrees east, to a point B. Then, given the distance between the distance covered by the aeroplane was 800 kilometers. So determine the position of B. Determine the position of B. So that is those are the questions. Now let's go to the first part of the question. And the first part of the question is the distance. You're supposed to calculate the shortest distance between the two cities. So the first thing we're going to do is to sketch the positions of these places that are given. So let's sketch. So you have 60 degrees north, and you have the 60 degrees north. They have longitudes here. We have 129 degrees west. You have the 21 degrees east. So this is the 31 degrees east. It's 29 degrees west. Then the latitude is 60 degrees north. So P is here. So this is point P. Then Q is here. So we're supposed to get distance between P and Q along the parallel of latitude. So that distance PQ is distance along the small circle. So distance PQ is distance along the parallel of latitude, or distance along the small circle. And that is obtained by this formula, theta over 360 2 pi radians cosine of alpha, where theta is the longitude difference, and then alpha is the latitude angle. So we need to get the longitude difference to begin with. So let's get the longitude difference. The longitude difference is obtained by, look at the two places. P is 29 degrees to the west, and Q is 31 degrees to the east. So to get the longitude difference, we add, this gives 60 degrees. So after obtaining 60 degrees, now we can, the latitude angle They lie on 60 latitude angle is 60 degrees. They lie on the same latitude. So distance PQ therefore in kilometers is given by 60 degrees over 360 multiplied by 2 multiplied by the pi we're supposed to use. We give it the pi, so you can use any pi here. So multiply by 22 over 7, which is pi, times the radius of the earth, which is 6370 cosine of 60 degrees. So that is what will give the distance in kilometers. And working out these very well using a calculator, you obtain 36.67 kilometer. So that is what you obtain, 3,336.67 kilometers. So that is the distance between PQ, that is along a parallel of latitude. So that is how we obtain that distance. Let's go to the other part. The other part we're supposed to get, we're supposed to obtain, if it is 12:00 hours at P, what is the local time at Q? So when you are working out time, we use the longitude to know the time difference. So we need to identify the longitude at P, the longitude at P, and the longitude at Q. So the longitude at P is just here, 29 degrees west. So 29 degrees west, then this one is 31 degrees east. So to get the longitude difference is obtained by, you add the two, 29 degrees plus 31 degrees, which gives 60 degrees. So that is the longitude difference. That is how you obtain it. After obtaining the longitude difference, there is always a difference or time difference between two longitudes. There's always time difference between two longitudes, and places to the east are always ahead of time as compared to the places to the west. And therefore, it is good to note that there is a difference of, for every 1 degree, is a difference of 4 minutes. So we want to get this difference, which is 60 degrees, will give a difference of how many minutes? So this will give 60 multiplied by 4. So this gives 240 minutes, which is equivalent to 4 hours. So this difference between these two longitudes, 29 degrees west and the 20 degrees east, there's a difference of 4 hours. Now, if it's a difference of 4 hours, we need to know the time we're given at P. So the time at P here is 12:00 hours. So places to the east are always ahead of time. Therefore, at Q, we expect Q to be ahead of time by 4 hours. So to obtain the time at Q, we simply need to take 12:00 hours. We add 4 hours. Since it will be ahead of time by the fact that it is to the east, looking at the longitude. So time at Q will therefore be 16:00 hours. So that is how you work out that part. Let's go to part B. Part B, an aeroplane flew due south from a point A, that is 60 degrees north, 45 degrees east, to a point B. The distance covered by the aeroplane was 800 kilometers. Determine the position of B, that is 4 marks. So let's go to the diagram. We identify these place. We locate these A 60 degrees north, 45 degrees east. So we shall add another longitude, which are not given here, 45 degrees east, somewhere there. So this is 45 degrees east. So A is located 45 degrees east, 60 degrees north. 60 degrees north. So it is somewhere here. That is where A is. So this aeroplane flew from A to a point B, that is due south. So due south means it flew along this meridian. So we can put maybe somewhere up to that point. So it flew from A, this is the point A, to B, due south. So due south means directly below, along that meridian. That is what we mean by due south. So look at distance AB. So distance AB is distance along the meridian, and we're given that distance is 800. So distance along the meridian AB, so distance AB is distance along the meridian, and that is distance along the great circle. That is, it is distance along the great circle. So to obtain that distance in kilometers, this is how we obtain it. Distance given by theta over 360 to pi radians, where in this case theta will be the latitude difference. Latitude difference, since when you look at this position of A and B, you realize they are on the same longitude, 45 degrees east, but they are located on different latitudes. So theta is the latitude difference. So A is 60 degrees north, we don't know B, that is what we want to locate. So therefore, there's this distance, which is 800 kilometers, is given by latitude difference over 360 times 2 times pi, 22 over 7, times the radius of the earth, which is 6370. So in this case theta will be given by 800 times 7 times 360, everything divided by 44 times 6370. When you work out this, you get latitude difference as 7.193 degrees. So this is the latitude difference. Now position of B, let us indicate the position of B. So position of A, can put A and B, both of them are okay. Position of A is 6045. 45 degrees east. Then position of B, X degrees, that will be X degrees. Now this will still be north, it will still be on the north, then the same 45 degrees east. They are located on the same longitude. So therefore, in order to obtain the latitude difference, which is 7.193, we use, this is what we use. That is what we use. 60, that is the latitude. This is what will give what we have here. Those two. So therefore, to get the latitude difference, we get, so latitude difference is given by 60 degrees minus x degrees, which is, latitude difference is 7.193 is equals to 60 degrees minus x degrees. So we are looking for that latitude at B, and this will be given by x degrees, therefore be given by 60 degrees minus 7.193 degrees, and therefore this gives 52.81 degrees. So that is x. Therefore the position of B is now, yes, so it will be 52.81 degrees north and 45 degrees east. So that is how we're supposed to work out that question. A tourist took 1 hour 20 minutes to travel by an aircraft from town T 3 degrees south 15 degrees east to town U 9 degrees north at 5 degrees east. Take the radius of the earth to be 6370 kilometers and pi 22/7. Part A, find the average speed of the aircraft. The remarks. B, after staying at town U for 30 minutes, the tourist took a second aircraft to town V, which is 9 degrees north, 5 degrees to the east. The average speed of the second aircraft was 90% that of the first aircraft. Determine the time to the nearest minute the aircraft took to travel from U to V. Then part C of the question. When the journey started at town T, the local time was 0700 hours. Find the local time at V when the tourist arrived. So let's begin with the first part of the question, which is finding the average speed of the aircraft. Finding the average speed of the aircraft. So to find the average speed, speed will be obtained by distance. So speed will be obtained by distance over time taken. And in this case, the distance that you're supposed to get is distance from T to U. So we need to get the locations of these places so that we know or we establish whether they lie on the great circle or the small circle. So let's sketch. The locations of these places, that is T, U, and V. Now let's go to the question. Find the average speed of the aircraft. The aircraft moved from T to U. From T to U. So look at that distance. T to U is distance along the meridian. So that is distance along the meridian. So TU is distance. This is distance along meridian or the great circle. This is the great circle. So we obtain that distance, this formula. So distance is obtained by theta over 360 to pi radians. That is how we obtain such a distance. Create space. So in this case, we have theta, which will be, you can see T and U lie on the same meridian, so you have to get, this will be the latitude difference. So one is to the north, 9 degrees north, the other one is 3 degrees south. So the difference will be 3 degrees plus 9 degrees, which gives 12 degrees. That is the latitude difference. So distance, therefore, TU be given by 12 degrees divided by 360 multiplied by 2 by pi multiplied by the radius of the earth. So that is what will give the distance. So that distance will be obtained when you work out that. You get 34.6667 kilometer. So that is the distance. Now what we need to get now is time. Already we have time. Time is given as 1 hour 20 minutes. So 1 hour 20 minutes. So we are good now to get the speed. So the speed will therefore be given by distance, 34.6667 kilometers, divided by 1 hour 20 minutes is same as 1 1/3 hours. It's the same thing. Working out this gives 1001 kilometers per hour. So that is how you're supposed to do that part of the question. So by simply getting the distance and the time that you're given, 1 hour, this is 1 hour 20 minutes, is equivalent to 1 1/3. Let's go to the second part of the question. After staying at town U for 30 minutes, the tourists took a second aircraft to town V, 9 degrees north, 5 degrees east. The average speed of the second aircraft was 90% that of the first aircraft. Determine the time, the nearest minute the aircraft took to travel from U to V. So we need to get the nearest minute the aircraft took to travel from U to V. So we need to get that time. Now to get time, we need to get this time, we need distance over the speed taken by the second aircraft. Now let's start with the distance, and the distance we're going to cover here will be the distance from U, so U to V, distance U to V. Now look at these sketching that we did for the positions. U to V is distance along the small circle. So UV is distance along the small circle, or the circle of latitude. So, and to obtain that distance, this distance is given by theta over 360 to pi r cosine of alpha. Now in this case, theta will be the longitude difference then alpha will be the latitude angle. So we need to identify these. So we have distance uv therefore will be given by, now the longitude difference, one is 35 degrees east, the other one is 5 degrees east. So the difference will be obtained by subtracting 35 minus 5 degrees. So that is how we'll get these. So this will be 35 degrees minus 5 degrees, which will give 30 degrees. Then the latitude angle, they lie on the latitude 9 degrees. So 9 degrees. So 9 degrees, that is the latitude. So let's now go ahead and get the distance. So distance given by theta, which is 30 degrees, divided by 360, multiply by 2 by pi by the radius of the earth, multiply by cosine of the latitude, which is 9 degrees. So that will be the distance. So that is the distance uv. Then to get the speed, let's go to the speed. We're given that from this statement here, this statement, that the speed was 90% that of the first aircraft, the speed of the second aircraft. So therefore the speed will be 90%, to be 90%, which is 90 over 100 times the first one. So that would be the speed of the second one, the second aircraft, because it is 90% of the first one. And the first aircraft, the speed of 1001 kilometers per hour. Therefore, the time, just to simplify this, the time taken by this craft is given by the distance. Distance which you have obtained here is 30 over 360 multiplied by 2 multiplied by 22 over 7 times 6370 cosine of 9 degrees, everything divided by the speed, which is 90 over 100 times 1001. So that will give, the whole of that will give the time. Now, for the interest of saving time, you work out these using the calculator, and when you work out that, I've already done it, so you get this, so you get 3.658104 into 565 hours approximately. This is approximately 3 hours. It will give 3 hours and 39 minutes. So that is the overall time taken by these second aircraft. So we began by getting the distance and then the speed, dividing by the speed. Now let's go to the third part of the question, which is the last one, is the last part of the question. Now when the journey started at town T, the local time was 0700 hours. Find the local time at V when the tourist arrived. So the first thing will be to get the arrival time at U. The arrival time at U. So from T to U, that one we given took 1 hour 20 minutes. So if the journey started at 07, also the first thing we write is arrival at U. So if the journey started at 0700 hours, the first thing from T to U, 1 hour 20 minutes was taken. 1 hour 20 minutes. That is to arrive at U. So arrival at U was 08020 hours. Then departure at U, Now look at the statement here. The statement here that this statement is here is after staying at U for 30 minutes. This is a statement here. After staying for U for 30 minutes. So this aircraft stayed at U for 30 minutes. So after arriving at U, 30 minutes extra, we have to add these. So 08, I'm sorry for this. So 0820 hours plus 30 minutes. That was the amount of time spent at U. So this one, it left at 0850 hours. Then, now what you're remaining is U to V. U to V. U to V. U to V. Now when you look at the sketch, the positions of these places, now moving from U to V means moving from one meridian to the next. And when you're moving from one meridian to the next, there will be time difference. Between meridians, there's time difference. So we have to be careful about that. Time difference between U and V. So let's get that time difference first. The time difference. So at U, to get the time difference, we use the longitudes. So at U is 35 degrees east. 35 degrees east. So U, this is 35 degrees east, and V is 5 degrees east. So that is very important. So to get the time difference, between U and V be given by longitude difference, which is 35 degrees minus 5 degrees, which is 30 degrees. Then 1 degree is equivalent to 4 minutes. So what about 30 degrees? This will give 30 times 4. This will give 120 minutes, which is equivalent to 2 hours. So there's a difference of 2 hours between these two meridians. It's very important to note. So arrival time at V, so therefore arrival time at V will be calculated by the time it left U was 0850 hours. 0850 hours. Then the time taken to travel from U to V, we calculated these in this part of the question. We got that to be 3 hours 39 minutes. 3 hours 39 minutes. Then after getting all these, note that at V will be behind of time by 2 hours. These 2 hours difference between the meridians, since when you look at U and V, the one that is to the east is U. So U is ahead of time by 2 hours, and therefore V is behind of time by 2 hours. So to get the local time at V, the second aircraft arrived at V, we have to take care of that time difference. So noting that V will be behind of time by 2 hours. So after doing all these, you forget to subtract 2 hours in order to get the local time at V, that is brought by the longitude difference. So adding these and subtracting 2 hours, This is what you're supposed to get. You get 10:29 hours. So that is the local time at V, and that is how you're supposed to solve that question.